In this particular lecture, we'll be discussing about the software requirements of a safety instrumented system. If you have followed my earlier lectures, we have discussed earlier about risk analysis or risk identification and risk reduction methods. And as a part or outcome of the risk analysis, we got SRS or Safety Requirement Specification. Now, the safety requirement specification is created by the end user, and but end user always does not do everything like from the system integration point of view. So they normally give the SRS to the system integrator, which can be DCS PLC vendors or any other consultant in this regard. So what the system integrator basically does is converts that SRS to the hardware and software requirements. So in this particular section, we will be talking about that software requirements of a safety instrumented system. So from SRS, you get two parts. One is hardware requirement and another is software requirement. And this SRS actually gets generated out of the risk analysis, which can be in the form of HAZOP, LOPA, FTA, etc. Now, think of a SIS system. What the SIS system is and what it contains. So, to be very brief on that, it will be there will be an initiator, there will be one logic solver, and there will be one final element in a SIS loop as a minimum, right? Now the initiator may be a transmitter, and then it will be connected to a PLC, and then it will be connected to a on-off valve or XB. Now if you see the software requirement for the pressure transmitter and the valve, so the valve, if it is on-off valve, there is only solenoid and it is getting connected to the XB. In case the valve has partial cross testing, there can be provision of positioner into it, and that may contain some sort of software. But the software at positioner and the pressure transmitter, that means the initiator and the final element, is very minimum. All the softwares are basically lies in the logic solver section. So when we define the software requirement, it is mainly about the logic solver. But though the systems like initiators and final elements are gradually improving, and there are lots of software components getting added into it. So there is a possibility of software requirements in that parts too, right? So for this section, but we will talk about only logic solver. So when we say the logic solver again, there is a PLC, and the PLC is connected to a engineering workstation. So engineering workstation basically to configure and making the logic everything, and the PLC is getting connected to all the IOs, input and output, which is the pressure transmitter, all the valves, everything, right? So let's now see how let's remove all this thing and let's see. Just it is taking some time, sorry for that. Okay. Okay. Now if we see PLC, there will be engineering workstation, There is a programmable electronic safety system, which is in this case PLC. Now, in the PLC, there are two different kinds of software. One is application software and another is embedded software, right? And in the PLC, there can be additionally diagnostic software, support function, and operating system. Again, there will be libraries, there will be SIPs that are defined into this application software, right? So these libraries and these SIPs, they are the part of the application software, and this diagnostic feature, support function, and operating system, they are part of the embedded system. Now, engineering workstation will develop all the logics and by using this application software and then push it to the PLC, right? So in the PLC we do all the function that are executed are done in this PLC. Okay. Now these are the type of the software that are being used. So now if we see the language, what are the software development language that are being used in a PLC? So there are mainly three languages. One is full variability language, another is limited variability, and another is fixed programming language. This is for PLC and any field instruments. Uh, Both we are discussing about both. So if it is a full variability language, so it is mainly C, C++ or embedded level language. If it is a limited variability language, it is functional block and ladder logic. And if it is fixed programming, it is mostly like push button that you can normally see in a pressure transmitter, or in case some positioners you will be see up down buttons there to configure and configure that particular instrument. So in case of the full variability language, all the requirements are specified in the IEC 61508. In case of limited variability language and fixed programming language, all the requirements are specified in IEC 61511. So if we want to see the actual requirement, we need to go into the standards and we need to see what are the requirements are, what we need to follow, right? But in the high level, I am giving a very high level picture here. Later on we will discuss the what are the exact requirement are that needs to be followed. ISA 61511 does not differentiate between SIL-1, SIL-2 or SIL-3 software. Their requirements are unified for all the three levels, SIL-1, SIL-2 and SIL-3. And software beyond SIL-3 requirement are not in the scope of IC 61511. For that you need to again refer IC 61518. So that's it from the software requirement side in this lecture, and in the future we'll be discussing about the exact requirement of the software, but at least you have some idea now what are the different softwares and where which standards to refer for the requirements, right? Okay, thank you.